Okay, now this first couple that we do won't really be about limits because where did we start yesterday? What's the title of this? The average rate of change, right? Well, we didn't even talk about instantaneous rate of change, but the reason I kind of jumped over that was the main idea of this lesson is really about limits, but they give you a few of these at the beginning, so let me show you how these work. These will be the simplest ones. They're more like, oh, you just plug this into that and that sort of thing. The directions say an object dropped from rest from the top of a tall building falls y equals 16 t squared feet in the first t seconds. Find the average speed during the first 3 seconds of fall. Okay? I'm sorry, that was number 1. Number 2 says find the average speed during the first 4 seconds of fall. Okay? Well, we're dealing with y equals 16 t squared. That's crucial to know in order to answer the question. Where do we go from there? And what is the average speed formula? It's what? Slope. So what do I need? Okay, rewind. Before I can start using the formula, what do I have to have? Stuff to put in it, right? I need coordinates, don't I? Okay. Well, what are the coordinates at the instant the thing takes off? 0, 0. Because it has not fallen any, and time is 0. And it says in the first 4 seconds. So,
1:16.
and then that's the other thing is you can literally plug the x in to get the y, right? So if I plug 0 into 16t squared, I get 0. So what's my x coordinate now? 4. So I'm going to plug 4 into 16t squared. So I get 16 times 16, 256. Yes? So now we have our coordinates. So the average speed, and you should write this down, because if you don't write the left side, when I tell you to look back at a particular problem 2 or 3 weeks from now, 6 months from now, and you didn't write anything there, you're like, why were we doing the slope? But if you write average speed, you'll remember that's the same thing in essence. All right, so we can start with either one. Let's start with 256 over 4. And then the minuses behind those, we will have
Teachers,
0
anyone that
and 0.
has not picked up their elite pad but has paid for their insurance, please report to room 406 at this time.
Well, that's
All
an
students that have
interesting
not picked up their
stipulation.
elite pads but
They
have
didn't
paid
mention
for their
yesterday.
insurance.
All right, so then we divide, and 4 goes into 25 how many times? Okay, that's not what I asked you. Answer the question I asked, not the one you wish I had. Why might I be asking you these questions? Because there will be many, many, many times between now and the time you take the AP exam and the day of the AP exam where you don't have a calculator. You want to get fast at this. 4 goes into 25 6 times with what left over? 1 left over, so put the 1 in front of the 6 and make it 16. 4 goes into 16, 4 times. So the average speed is what? Thank you. I will tell you that on the AP exam, when you have problems involving units and you leave them off, in all likelihood, you've cost yourself at least a point, and in some cases, multiple points. Okay? Points matter. I will also tell you on the AP exam that your answers are required to be to 3 decimal places of accuracy.
That's what 4.000.
No, if you leave that, that's accurate because the zeros are implied. But if the answer were 64.013 and you just wrote 64, you would not get credit for your answer. So whatever points that was worth, you would lose.
This is a question. I know like speed can be like negative, but since it's dropped, wouldn't it be like it fell at like negative 64 feet per second?
No, that would be the velocity. Velocity can be negative, and we'll talk a lot about that too. That's a good question though. But think, and when you're trying to decide whether to make the answer negative or positive, you have to think about it in the context of what's happening. What do we know about the object? It's falling. The speed is what? Like how fast it's falling. Do you see what I'm saying? So the direction is given, so the speed is just how fast it's going. Does that make sense? Good question though. All right, let's look at another. So we can move on to some real problems. I don't see an instantaneous speed problem up there, but they're going to ask you that at some point. So you can look back at the example, and if you don't find it, we'll go over that tomorrow if I don't get to it today. All right, because I want to stop in time for y'all to at least do a few. All right, in exercises 5 and 6, use the limit as x approaches c of k equals k. The limit as x approaches c of x equals c, and the properties of limits to find the limit. Now, when you do this assignment, and I won't ask you to do this forever and ever and ever, but here's why you need to, well, I'll tell you why after I tell you what I want you to do. I want you to basically do all of your work this way, like we're about to do 5, or not 5, we're gonna do 6, you're gonna do 5. But the reason I want you to do it this way is that, and let me flip it around and ask you a question. Have you ever learned something in math that it sounded scary, but then when you looked at it, it was like really simple? So you just did your homework, and the homework didn't even cause you to strain yourself because it was just so straightforward, and you just used that same idea over and over and over again. And then 6 months later, you were asked to use that same property or definition or formula, and you're like, what? You know why? Because you didn't have to strain for it, right? These properties are going to be the same way, because what is the limit of a sum? Right. You see what I'm saying?
Yeah.
So it's going to be the same kind of thing that it's just going to roll off your tongue. So you're like, well, that's obvious. So what's going to happen is you're going to find the limit on here, on your homework, and if you don't write these out the way I'm showing you now, you won't remember how you could prove it. If I say prove or verify, I'm looking for what we're about to do here. So this is kind of like a proof on number 6. All right. So we have the limit as x approaches c of this lovely, lovely, lovely rational function. We have x to the 4th minus x cubed on the top, plus 1, all over x squared plus 9. And the directions told us that the limit as x approaches c of k is k, that the limit as x approaches c of x is c, and the properties, and then we have to show the properties here. All right, so what would be the first property we're going to apply here? This is a quotient of polynomials, isn't it? Right? So we're going to apply the quotient rule. What does the quotient say? Okay, what is the limit of a quotient? The quotient of the limits, which means we can find the limit of the top, the limit of the bottom, right? Okay, so I'm going to write equals, put a long bar, and then we're going to go term by term. All right. So the first thing we come to, and I'm doing this in like zoomed in slow motion to help you realize, because some of you will come back on Tuesday and say, I didn't feel like I used any properties when I did this homework, but I got all the right answers. What happened? And this is what's going to happen, okay? You're so used to thinking of a polynomial as one thing, you don't think about the fact that it is a sum of little things, okay? So x to the 4th is a what? It starts with a p. It's not quadratic, it is to the 4th power. It's a power, right? Okay? Don't we have a property for that? What does it say? The limit of a power is the limit, it's the limit raised to the power, right? Yes? Okay, so what do I put for the limit as x approaches c of x to the 4th? C to the 4th. Why? Because what is the limit as x approaches c of x? According to the directions, it's c. Yes? And what is the property about the power? The limit of a power is it's the limit raised to that power, right? So I just took the limit of x, which was c, you with me? And stuck the 4 on it, because that's what that property says. Can I find c to the 4th power? No, because I don't know what c is. That's all I can do, right? Next term is minus x cubed, right? Why am I going to go ahead and write the minus? Because what would that minus technically be relative to our properties? A constant? What constant would it be if it's not plus, it's minus? -1, right? So it's like it has a -1 coefficient, right? Why can't I just stick that on there? Tell me which property. You don't have to think it through. You can actually look at your notes at the properties. There's a property that tells us we can just leave the minus there. That's right, the constant multiple, right? Because I can think of a minus as a constant multiple of -1. Does that make sense? So I can just write the minus, and then I have x to the 3rd. How do I handle that? C to the third. Whoop, whoop. How about the limit as x approaches c of a constant? Remember I pointed out yesterday that that's really just a horizontal line? Whatever I approach on that line is going to give me back what? The same thing, and in this case that's going to be plus 1. Okay, now let's boil that down to a short story. We went into the zoomed in property by property approach, but what's another way we would have gotten the same result? If we had plugged in C for X, right? You see what I'm saying? But you really have to think about the properties to kind of incorporate them into your thinking, because you'll need the properties at some point and you won't have them because you were just plugging in the whole time. You see the difference? On paper, I won't see the difference, but you'll know that you screwed up when you get to one where you need the properties and you're like, I don't know how to do this. Okay? So it's going to kind of catch you up. All right, so on the bottom we have x squared plus 9. So we're going to start with x squared, which is a power. So we use the power rule, which says that the limit of a power is the limit raised to the power. So what do we write? C squared. How about that constant? It's the same because the limit of a constant is the constant itself. And we've done that. Now see, on paper you can't tell we did anything different than other than just plugging it in, right? So I'll figure out which way you did it by way of asking you a couple of questions you can't answer at some point. All right, any questions about that?
That was it? That's how you do that.
Yeah, this is one of those lessons that you have to spend a lot of time discussing the ideas behind all of it. You have to, because it's foundational to everything else we do. And the homework is like, really? Really? This is it? But then again, when you get to the hairy ones, you're going to be like, oh my God, I hate limits so much. And then when we're starting to study for the AP exam, you're going to be like, oh my God, how do you find the limit? I mean, that's one of those kind of things. So yeah, it should be by nature be simple. And why will this one be even simpler when you look at number 8? Look at the directions. What do the directions say? Substitution. That is the big kid word for what? Plug it in. All right, so now we're going to do one with an actual limit. The limit as x approaches -4 of x plus 3 raised to the 1998 power. Don't panic, and this is not a calculator question. Okay? Even though they don't put a gray bubble on it, I would smack your hand if I saw you reaching for one on this problem. So if we're going to plug it in, what we're going to write is, and here's the thing, you write the limit part in front of something until you actually take the limit, okay? Notice when we did and this is sort of a subtle thing that might have snuck past you on number 6, the only place we wrote the limit as x approaches c was in the original problem, right? Why didn't we write it on the next one? Because that's right, because when we wrote that step, which there was nothing else we could do to it, when we did that step, we were taking the limit. So when you're substituting it in and getting a real result, you are taking the limit. Does that make sense? All right, so what are we going to do? What's going to be inside? -1, right? When I plug -4 in plus 3, I get -1. Now you understand why that exponent's not so scary? I'm going to let somebody else explain it.
Plug in -4 for x.
That means
And honestly, I did it for 2 reasons. For one, the directions told me to. But what would the other reason be? Because that's the first thing you should try. Okay, you see how simple it is, and that's what you hope for. And believe it or not, you may have one exactly like that on the AP exam. That simple. That all you have to do is plug in the number, get the answer, bubble in the right letter. So there are questions that simple on that exam. All right, so why is this stupid simple? Because it's 1 to a power, and why is it positive? Because the exponent is even. Okay, good. We haven't forgotten our basics, or at least not those. Let's talk about 12. Not that I really want to, but that and it's not like it's that bad, but it's just I already know there's a reason I'm doing it, and I guess I'll wait and let you have that response when you see what it says. The limit as x approaches, There was a fly on the microphone. If you hear a buzzing sound when you watch this later, you know what it was. The limit as x approaches 1/2, and then it has INT(x). What is that? The interstate. The limit as x approaches.
The interstate. Any interval.
What was it? It is a must-know function. That's why you must know it, and I will not tell you what it is.
It's the imaging word.
No. I understand why your brain went there. Probably nobody else in the room would get it. She said, is that the 1/x? What is the name of the 1/x function? It's the inverse function, so the IN might trigger, oh, it's the reciprocal function. No, it's not. Come on, guys, there's a horrible pause in the video right now because y'all are all looking around waiting for somebody. The greatest integer function. It is the greatest integer function. It's the this one has several names. Step function, greatest integer function,
Oh, it's
right? The one that looks like steps without risers. Yeah, there's a hole on one end and a closed dot on the other. Okay? Now, so I have to, where is 1/2 between what and what? And remember, where is the step relative to the x-axis? At from 0 to 1. On it, right? Remember, if you graph that on your calculator, you can't see that step if you have a black and white graph, right? Or you don't have a color graph. But the first step runs from 0 to 1. Do I care whether the dots are open or closed while I'm answering this question? Because what am I doing? Now I'm zoomed into that one little step. So what would the limit be? And what did it say to do by substitution? So what would my written work be for this one? Equals INT 1/2, right? Which would mean absolutely nothing to you if your friends hadn't followed my suggestion that you put your must-know function packet and other pre-cal resources in your binders for reference. And for those of you who have not yet done that, you need to do that by Tuesday so that you don't have to rely on other people to help you do your thinking. All right? So, when I'm on that step, zoomed in around 1/2 on that step, which would be obviously in the middle, the literal mathematical middle of that step, right? As I approach it from the left, what's my y value?
0.
If I approach it from the right, what's my y?
0.
So what is that?
0.
So not only that, but if I'm thinking like from my calculator's perspective, what is the y coordinate at 1/2? It's 0, right? So I'm showing you multiple ways that you know that the answer is 0, and our work here is done. Okay, and I want to explain these to you, but I don't want to actually take the time to do one because I think they're pretty self-explanatory. I'm kind of skimming to see what else you're going to have trouble with. If you look at the directions for 15 through 20, and this is one of those deals just because of the way it printed on the page, a lot of times students are like, what the heck are we supposed to do? You are supposed to actually copy that table for A and that table for B for each one of those. And you are supposed to put the y values in. And then you are supposed to determine the limit from your table. Do y'all want to do one of those?
So you just plug it all
That's
into
what
your
we
calculator.
do.
Well, now, the only difference between what we did yesterday and this, and the reason I was asking is that I don't think you need to know how to do it in terms of understanding what it's asking you to do. But you're using those functions up there at the top. I've actually had some students like, where are the functions? I'm like, right here. So they're 15 through 20. But notice that your x values are not by increments. Do you see what I'm saying? It gets tinier and tinier as you go. Are you with me?
Yeah.
So what I would suggest is that if you have an Inspire, in fact, I think I would do this on either calculator. Do y'all remember how to store a value on your calculator? Let's do that right quick if you don't remember. And if you remember, you don't have to do this. all right? Get your calculator out, and on the 83s and 84s that you have, you are, okay? And then put x squared plus 6x plus 2, close parentheses. Will you stop looking at me? You're taking like 20 minutes to type it up. Plus 2, close parentheses.
Oh, minus 2, hold up. You need a charger over here.
Divided by, and on the bottom you need another parenthesis. Left parenthesis, x plus 1. So when Mackie's really loud on this part of the tape, you know why. He was up here spitting on my mic. Okay. Now hit enter. And you get a value, right? Okay. Now, you can recycle that expression because that was for the first one. So you would write that down in your table. And then negative 0.01 is what you want to store now. So type negative 0.01. In fact, do this. If you have an 83 or an 84, do second enter. And if it's not the one you want, hit clear. Because what you want back is where you did the store step. Yes? God help us. We've got to do something about that Casio. Clear. That's not the one you want. Because we're going to do a different store. Okay, now insert in front of the 1 a 0.
How do you do that? I was wondering how to do that the other day.
So you're highlighting, you put your cursor over the 1 and then do second insert and put a 0.
Miss Tweedy, how do you get it like when we're done doing all this, how do we unstore it?
What do you, which kind of calculator do you have? Let me pause the video. I'm gonna just